It got interrupted, so let's move forward with this problem. And we were discussing this truss. Remember, you need to cut, minimize the number of reactions, free body diagram, scalar equation. So what I'm going to do is just go real quick over it, and I want to give you the opportunity to work on the problem. So I'll just leave the equations expressed. Okay, so here I have 1,000 newtons, and if I'm doing the moments about C, the perpendicular distance from that force to C is 4 meters, and in this case it's a positive moment, and then I have plus the force GF, and the perpendicular distance to the force is 2 meters, and this is a negative, so here is a 0, so that's why I know this FGF is in compression. So that's how I would get FGF. And then now if I do sum of the forces in X equals 0, and remember you have to be critical and smart about how to do it, because now if I do the sum of the forces in X, then well, actually I should do sum of the forces in Y first. Sum of the forces in Y equals 0. Let me erase this. I guess I was not too smart about it. So sum of the forces in Y equals 0. I have the minus 1,000 newtons plus F GC, and this would be sine of 45 degrees, and I don't have any other equations in Y, so then I get FGC, so this is known now, this is, and then now I do sum of the forces in X equals 0, and then in X I have minus FGF plus FBC plus FGC, and then I have cosine of 45 degrees equals 0. But then now I know from here FGC, from here FBC, so I can solve for FGC. And then practice doing the left hand side, but remember, before you do the left hand side, the whole structure, you use it to calculate the support reactions, not just the right hand side, because you have too many unknowns. So you have to use the whole structure to calculate the support reactions. It cannot be cut. Okay? So let's do one more example, and I'll leave it expressed again, but I think this one you have the answers in your book. So the loads are shown in this truss, and the force in members KJ, KD, and CD. So this really is telling you where to cut it, and that's good. Okay. One of the things is that there's an angle phi, so we can calculate that angle. Let me just see this first. So you take that cut, and would you work with the left or the right piece of the cut sections? Well, it can be either one, but if you look at the equations, the number of unknowns, you'll figure out that the left hand side is better to determine. So I want you to do that exercise to practice, and we have to determine the support reactions at point A, and only at point A if you use the left hand side. If you use the right hand side, then it's at point G. And then of course you apply the equations of equilibrium to solve for those forces. So this was the cut here, and then to determine that angle, if you look at the geometry of that section, here you have 2, and then you have here 3. So this is your angle P or phi. I don't know how you would call that. And we can solve for that angle, or for now let's leave it like that as the slope for a moment. Let's try and solve this. So we have to do the left hand side, as I said, but before doing that we need the support reaction on A, which is, it would be like this. So you have AY and AX. Here you have GY only, and in this case, if we do sum of the forces in X equals 0, then AX is the only force, so AX equals 0. And then we need to calculate the support reaction in A, so we can calculate the moment about point G. And here is equals 0. So we have AY times 10, and that would be a negative moment, and then I have plus 20 times, oh no, it was 12. It was 12 here, not 10, because here then it's 10 plus 30 times 8 plus 40 times 6. And then this equals 0, so AY equals 56.7 kilonewtons. Okay, so now we have AX, AY, and we could solve for GY as well if we wanted to, but we're just going to use the left hand side. So now that we have the support reaction, we'll then have the cut, and remember this one here goes up and it's 56.7 kilonewtons. So that's all that we have. And then I draw my free body diagram for my left side, and of course I don't know this AY, so let me do as good as I can. So this is 56.7 kilonewtons, and then we have a truss here, and so this would be like this. Oops, let me do a better job here. Oops. When it gets real close to the top, it does this. So, okay. So this here is A. This is L. This is K. This is B and C, and so if we continue this, this would be here point D, but of course I'm going to leave it like this, and then my dimensions, which here are 3 meters, and then 2, 2, 2 meters. Okay, and then I have to include the other 20 and then 30 kilonewtons. So let me change the in color here for a moment so that we can clearly see what forces we have here. Okay, and then this here would be point J. So I think that should be it. So whenever we look at this, and we did some of the forces in Y, and then remember what are the forces that we want to calculate: F, Kj, F, Kd, and F, Cd. So if I do some of the forces in X, I have 2 unknowns. But if I do some of the forces in Y, I have only 1 unknown. And we can either calculate, let me do it here. Here you had your 2 and then your 3. So you can either calculate this angle here or calculate this here to calculate the slope. So it's 2 squared plus 3 squared. Okay, so this would be the square root of 13. Okay, so you can also use that, either one. It's more exact if you can use just these ratios here. So let's do sum of the forces in Y equals 0. Remember, I'm using this left hand side section, so I have 56.7 minus 20 minus 30 minus FKD, and then it would be Y, so it's the 3 divided by the square root of 13 equals 0. So then FKD equals 8.05 kilonewtons, and this is in tension. Okay, so then, sorry for that interruption, if I do now some of the forces in if I do some of the forces in X, I have 2 unknowns, right? Because I have the CD and F. Okay, so then I look at the moments. So that way, if I do some of the moments at point D, I can solve for the force Kj. So sum of the moments at point D, and I do this, equals 0. So I have 56.7 66.7, and this is kilonewtons, times 6, and this would be negative plus 20 times 4, it's positive, plus 30 times 2, and then I have minus the force kj times 3. Okay, this equals 0. So the force kj equals negative 66.7. So I know it's in compression, so I can leave it expressed as negative, or say it's 66.7 kilonewtons, and it's in compression. Okay, so whenever I'm going to do the sum of the forces in X to find the force CD, which is the one that I'm missing, I can either leave this negative and just leave it like I have it in the free body diagram, or change it. So what I want to do is I'm going to erase these parts. Remember, you can always pause everything and see it, and after Monday's class I will have all these solutions uploaded. So let me then solve for the forces in X. So what I have so far is, let me recap the forces that we have, and I'll do it in blue. So what I have so far is force KD, this here is 8.05 kilonewtons, and this is in tension. And force F this was KD, this force here. And then force CD here is 62.2 kilonewtons. I'm looking at the wrong. The one that I want to determine is FCD. So I still don't have this one. But I have KJ, this force here is the one that's negative 66.7 kilonewtons. So let me just put it here. So I have the force KD and KJ. We said this was 8.05 kilonewtons, and it's in tension. And then KD is, this is 8.05 kilonewtons. Sorry, here. It's like I'm not very efficient now, but so I have KD, and then CD is the one that I need to find, and then KJ is the one that was minus 66.7 kilonewtons, or 66.7 kilonewtons, and it's in compression. So the point is that I can leave it like this. So whenever I do now sum of the forces in X equals 0 to calculate CD, I can say, okay, it's minus 66.7. I'm going to leave it like that. plus, and then it's 2 over square root of 13 times 8.05 plus FCD equals 0. So now FCD equals 62.2 kilonewtons, and it's in tension. Okay, so this is the second example, and as you can see, it's no different than anything we have done so far, except that we just need to be smart about the order of the reactions and where to cut the truss. So I hope this has been helpful, and good luck.